Hello and welcome to this problem on solving simultaneous equation using matrix. And this is an iGCSE additional mathematics question, and it's also suitable for further pure maths 1 and for high school algebra. And it says, given that matrix A is what we got as 7846, find the inverse matrix of A. So to find the inverse matrix of A, firstly we need to find the determinant of matrix A. And we find the determinant usually by finding the product of the numbers that occupy the northwest southeast diagonal, in this case 7 times 6, minus the products of the numbers in the northeast southwest direction. In this case 4 times 8. So 7 times 6 minus 4 times 8 gives us 10. So the determinant is 10. Now to find the inverse matrix, we need to multiply the inverse of the determinant by what's in the bracket here. Now what's happened here is that 7 and 6 have swapped positions. And we then multiply for the numbers running in the northeast southwest direction, we multiply by minus 1. That will change the signs of those numbers. So for this question, you can actually stop here, or you can multiply what's in the bracket by 1 over 10, and we end up with this one there. So you can end up with 3 over 5 minus 4 over 5 minus 2 over 5 and 7/10. Now add of these is correct, so you can use another for that one there. So you can do some extra work, it doesn't really matter. I hope that makes some sense. Now for part 2, and that says use your answer to part 1 to solve the simultaneous equations 7x plus 8y is equal to 39 and 4x plus 6y is equal to 23. Now if you look closely, you can identify matrix A there, 7846 there. So writing up properly in matrix format, we end up with 7846 times the matrix with xy, that's equal to 3923. Now what I want to do is to eliminate 7846 from the left hand side, leaving only this matrix there. Okay, now if you multiply both sides by the inverse matrix, we have this. Now to try and explain this, if you have 1 over 5 times 5, you get 1. Now the equivalent in matrix format would be multiplying the inverse of the matrix by the matrix itself, and you end up with unit matrix 1 0 0 1 at xy. Now this one here, you can imagine this as multiplying 1 times 6. 1 times 6 is 6. So if you multiply a vector by the unit matrix, you end up with this. Sorry, if you multiply a matrix by the unit matrix, you end up with the original matrix there. So multiply 1 0 0 1 by xy will give you xy. So that will disappear. Right. Now what you then know, now you can do the normal matrix multiplication. So you do 3 over 5 times 39 plus minus 4 over 5 times 23. That should give you 5. And for the y value, you do minus 2 over 5 times 39 plus 7 over 10 times 23. So we end up with xy and 5.0 and a half. So x is 5.0 and y is a half. Now can you go back and check that this is correct? Using substitute your values for x and y in both equations. Now I hope all that made some sense. Please subscribe, and thank you for watching. Bye bye now.